All right, let's start. Last day of math finance. Yay. Any questions? All right, so don't forget your final, right, is on May 5th, which is this Thursday, right? In person, of course, like usual. It's not here, okay? It's here 705, so the 7th floor. 703, whatever, I don't know. I mean, you go up there, you see the room right next to the elevator. I'll be there 9 to 12, right? I believe. If there's anything wrong, I'll let you know. Okay. All right. So let's finish where we started. Before we start, just one question. So from the homework of last week, it seems like you tell me that, so what's the deal with, foreign stock listed in domestic market? Or, domestic stock listed in foreign market, whatever. So I don't know, you told me that you couldn't find it, but so is it not listed? Or, like if listed, then in domestic currency? Meaning, so suppose you have Apple stock, then even if it is listed in, Europe or China, is still listed in the US dollars. And let me ask a very straightforward question, right? If you want to, let's say, buy Apple share, let's say in China, how do you do that? Can you even do that? Or, I mean, I understand there's legal issues probably, but these are interesting questions to ask. Because, I mean, really, it just more or less has to do with, the question of, are these things actively traded or not, right? Like American options versus like European option, right? I mean, it's kind of surprising that like the only thing that's actively traded is American option. So when you work with European options, in some sense, you have to pull out, right, the pricing formula because it's OTC, right? So I wonder if for these things, like the concept, right, of ST over QT definitely makes sense. But is it really actively traded in the market, or it's just really a concept that we discuss in the lecture? What do you find out? So is Apple listed in China at all? Can you buy Apple stock in China? You cannot.
I don't think so.
Can you buy any foreign stock in China?
So in person, and so not for the company. So if you're a person, you only have $50,000, you can use every year. So if you when you get the $50,000, you have to register a account in US, so you can kind of invest it by yourself.
Okay, but so that's fine. But then my question is, when you do that, do you buy Apple share in yuan or you buy Apple share in
dollar?
You buy Apple share in dollars.
Yes.
Okay, I see. Interesting. So there's no direct listing of Apple share in China with, okay, fine, got it. Sounds good. But on the other hand, right, okay, fine. So I see. So then I think the flavor is more like the OTC flavor. The reason, right, is this. You can still argue, right, that the person in China, in that story you tell, right, they still have to convert their yuan into dollars,
yes,
and then buy the Apple share, even if they want to. So there is that kind of taste. But these things are done by themselves, like you said, so in person, so it's OTC. So in other words, there's no listing actively of this. So there is a process like this, but so the difference between OTC, right, versus like, I don't know, listed, I think is that OTC is where our models are mostly appreciated. right? Because if listed, then you can just revert the numbers and use, linear regression techniques, whatever, right, to do it. But if it's OTC, then, there's no actively data listed. So you have to kind of use the model to do it. Yeah.
Question. But I think we have some company we can buy them in US dollar, but not Apple.
So you mean from a China's point of view?
Yeah. We have two different market. One is called A, another one is called B. So the B one, we buy stock by dollar, but not like company like Apple,
Right.
They're like some small company, I think.
Oh, I see. But they're a foreign company?
Yes.
There's some chat here. Let me see. But so what about the US side, right? Is there any US company? Okay. What's LSE? London. Okay. London Stock Exchange. I see. In US dollars. Okay. That's interesting. So yeah, I saw that. I saw Shinan's report. So that's why I asked. But so, okay, right? But so that's good to know. But on the other hand, suppose you want to buy Apple from London, right? Or if you want to buy Apple from Taiwan, do you pay in the unit of, right, pound, or, I don't know what Taiwan used, or do you pay in dollars? But either way, right, there should be a conversion somewhere because, right, understandably, people of that country, you pay in dollars. I see. So it's very similar to what Ife was saying, right? So, yep. So, okay. So I guess I can see the flavor more clearly now, right? That the okay. So the last question is there any foreign company listed in the US? I know Alibaba. Wait, Alibaba used to be listed, or was it listed at all in the US? Or was there talk about listing Alibaba in the US at one point? It's still listed or no?
Yeah, still listed.
I see. That's good because that actually is, but Alibaba definitely is also listed in China, right?
No.
Oh, interesting. So Alibaba is not allowed to be traded in China. It's only in the US. So also we don't have that.
I'm not saying not allowed, but
you cannot buy Alibaba.
Yes, Alibaba is not listed in China.
Interesting. So that is also a very interesting example.
Why, like Chinese government want a restriction.
Are they really afraid of people who try to trade currencies by indirectly trading stock or something? It's kind of weird. Anyway, very good to very interesting kind of things to look into, right? Because again, right, I want you guys to also try to see how the data fit to the things we talk about in the course, and not just, so yeah, so I guess until now, we still haven't found an example of a company that's listed in both countries in different currencies, right? But is there such a thing? But if not, right, I think this is still okay as in a theory to think about. All right, very good. So let us finish where we were discussing. All right. So so I understand the theory behind this is a little bit could be confusing. So let us kind of recap this a little bit, right? Change of numeraire. So first of all, right, the meaning in finance, right? The finance is just basically you measure, right, the value of an asset using a different units. And I want to emphasize this, right? It's not abstract, meaning we have done it all the time. You don't realize it, but it's all already there, right? So here are some examples. So first of all, right, I mean, the obvious one probably is the foreign currency thing, right? Currency conversions. So let me just do this, right? The ST over QT, right? But here you want to watch out, right? So, okay, QT is not a martingale, right? Under P tilde, but this will go through as was explained. So this is the obvious one, right? That basically you denote the stock in under a different unit. But there are two others that you have always been using that you have not really, we haven't really thought about change numeraire. The second one is just discounted price of anything. Right? So if you do discounted price of an asset, so basically right now, right, it's like this, right? Well, you don't think of it so much, right, as anything like a change in numeraire, but as I said before, right, you can look at it like this. And because E to RT, right, is exactly the price of a unit of the money market, right? So when you do discounted price of an asset, you are really measuring the value of that asset in the unit of the money market, right? So there is that change in numeraire that you've done already. The third one, which you might not see any distinction right now, but the forward price, right? The forward price of an asset. So do you know what this concept is? So forward price of an asset. So basically, right, this one is connected, right, with a forward contract. So, you know, the price of a forward contract, right, Vt equals to St minus K, then V0 is S0 minus K e to minus RT, right? This is the formula. However, this is more like a theoretical formula, because in practice, right, what people mostly done, and I don't think I saw any other cases, is they want the price to be zero, right? They want the contract to be free to enter. So in fact, right, it's really referred to as futures, but you know, we're just gonna blend these two terms right now. There's some subtle difference between forward price and futures price, which has to do with like a you know, a margin account, right? But we'll blur that difference right now. But anyway, right, the point is that any forward contract in market, right, should be free to enter. So basically that means that. But what that means is you have to set the K, right, at the right level, which means the K is S0 e to RT, right? Which, by the way, right, looks suspiciously like this, right? Okay. So what is this? This is the stock, right, divided by, so what is E to minus RT, right? So, okay, first of all, right, so here, right, this K right here, we refer to as the forward price, right, of S at time 0, right? Of course, for a execution or expiration at big T, right? But this one, right, E to minus RT, what is E to minus RT, right? Notice it's not E to RT here, it's E to minus RT. So what is E to minus RT? Price of a zero coupon bond, right? With face value, of course, equals to 1, right? We just kind of take that. But so, by the way, right, forward price is a very, very common concept, right, in a commodity market, right? Because what it basically does, right, you see, is what it allows for a fair trade, right, of a unit of that asset, you know, a bushel of corn, whatever, right, with a price that you currently set right now in the present, right? So you set a price in the present, and then in the future, right, you just pay that price for 1 unit of that commodity, right? So that's called, it's called forward price or futures price, right? For that reason. And so, right, but you see that when you look at it, it's really a change of numeraire, where, right, the numeraire is the price of the zero coupon bond, right? So it's fascinating, and I just want to tell you that, right, the theory of change in numeraire applies equally to all of these cases. Maybe not discounted price so much, because actually that's where we started. I'll explain that, right? But so all the things that so naturally what I want to say is this, right? In finance, funnily enough, right, the lesson that you learn here is, I mean, well, it depends on what you want to look at. But if you want to look at pricing, right, it's not like if you want investment is a different question. When you look at pricing, almost always you never look at the stock price as an entity by itself. You look at a stock price through the lens of others, right? Numeraire, right? Either the price of the money market, the price of your coupon bond, or the price of foreign currency. All right. So it's everywhere. All right. So that's a finance. Any question? All right. So now what about the math or the theory, right? The math theory actually is quite easy, but there's something to be said here. So the math theory is only this, that basically it says that the division, right, the fraction is a martingale under Pn. So basically, the ratio, right, of two martingales is still a martingale under an appropriate change of measure. Right? That's just really the message there, right? So what's the point, right? So you should appreciate this a little bit. By the way, right, I hope you understand that what operations can you do between two martingales that preserve martingale properties? What operations trivially preserve martingales? You can add and subtract, right? If you add and subtract martingales, it's still a martingale, right? Under the original probability, right? So here, you understand that what I mean is these two guys are martingales under some original probability, right? If you add and subtract them, they still a martingale under this original probability. But if you divide them, or for that matter, multiply them, right? They are no longer martingale, right? Under the original probability. But the message is if you change it right, if you look at it from a different lens, then it's still a martingale. Okay. So like a little bit more rigorously, more specifically, right? What we have is this. Let MT be a P martingale, right? MT can be anything it wants. And T also a P martingale, but you require it to be non-negative, right? I mean, to be safe, you can also assume that, but there's subtlety, but anyway, right? Why? Because you would use this, right? You use the N to change measure, right? So then you define Pn, right? Expectation under nu is the original expectation, and the change in measure kernel will be Nt over N0 times X. Okay, this is for X in Ft. All right, so this affects anything from time t backward. All right. So this, right, is your change of measure kernel. Notice that we divide by N0 because Nt doesn't necessarily have expectation 1, right? That's it. The theory says that then, right, Mt over Nt, right, for t less than or equal to t, right? And we also have a notation for this, right? It's just really this is a Pn martingale, right? That's the theory. All right. So, right. So here, right, the notation here suggests that here is the value of m, right, measure under the units of n, right? The value of m measure under unit of n, right? But so some, I don't know, annoying, right, issues to watch out for. The first thing is, right, so I hope it's clear what the finance, right, and the math says, right? I want you to kind of understand that these are very simple in of itself. There's some hairy issue when you try to connect the two together. All right. The first one is, right, what we call a numeraire. So what do I mean by this, right? So notice that in all the examples I look at here, right? None of the example are properly numeraire itself. Sorry, not properly martingales itself, right? They're not properly martingales. So the theory of the math, right, can be accommodating this by doing some discounting on here. But that will make the math a little bit really tedious to write down, right? Because you really just want to divide by 2 martingales, right? That's what you want to remember. For me, this is the nicest thing to remember. 2 martingales division, you change measure, right? There's nothing more simpler, more simple, right, than writing this. But when you come to finance, right, then you have to keep in mind that sometimes, right, you don't really want to go through the money market account, right? You want to really just use the, foreign currency, right? So that's why, right, it's okay to say that the foreign currency here is the numeraire, right, as a waving hand. It's not entirely wrong, but you want to make sure that, right, the math doesn't really say that, right? So basically, we may need a discount, right? To turn, right, the numeraire, the financial numeraire, into a martingale, right? So for example, right away, like, this guy, right? This is very, very natural, right? But, right, SFT is not, right, a martingale under P tilde F, right? That's not true. QT, or even that for that matter, E to minus RT QT is not a martingale under P tilde, right? But this is very nice for us to kind of write down. What's the right one, right? The right one, the mathematical formulation would be E to minus RF, right? T SFT, right? Which is equal to E to minus RT divided by E to minus RT, E to the RFT QT, right? This is a martingale, right? Notice how the math is much uglier. But why is this, right? Notice, right? First of all, there's kind of this weird lineup. There's an E to minus RT here that cancel with this, right? These two cancel, see? But here we need this because this is a P tilde martingale. This is also a P tilde martingale. But we also need this guy to turn this into the foreign money market. You understand? So I want you to understand that, right? All these are technical details that you need to keep right. You need to get right, right? So that you can match it up with the math theory. Okay. So if you don't get it right, then you will be off by a discounting factor or a unit, right? But it's much easier in finance to kind of talk to this about this object as a numeraire. You understand? So we will blur that a little bit, right? Like when you call the foreign currency a numeraire, or you want to call the money market a numeraire, that's fine, right? Is that okay? So that's what I want to say. The second one, right, is that when you do this, right, sometimes it could be like this. I mean, of course, it's already there, right? So basically, what I want to say is discounting may be ignored in some case. All right. I mean, discounting under the domestic risk-neutral, risk-free rate. The reason is, right, if this guy and this guy are not really martingales, but discounted is martingale, then, right? They both get applied by the same discounting factor like this. So really, right? The point is actually you should just do this over the foreign money market. That's all you need to do. That's all you need to, right? This extra thing doesn't do much. But if you don't do this, then actually it doesn't look like it's lined up with the math. Yet another annoying thing, all right? The third thing is watch out for the N0, right? Factor. In other words, right? Notice that when we do this, right? Again, it's very natural to forget the division by N0 here. You just want to use the change in numerator like this, but that's incorrect because, right? The change of measure kernel must satisfy that its expectation equals to 1. If you use NT by itself, the expectation may not be 1, and it won't be a probability when you convert like this. Why would that matter? So what that matters is because, which is like Q0 in the foreign currency case, right? Why it matters is because if you forget this, and I guarantee you that you might forget this, then you will get an incorrect conversion when you convert forward, backward. All right, so you may forget this. Right? What's an example? An example, right, is exactly that put call to RD. Where, right, it says that, so first of all, right, what is, so let's say we start out, right, with a call option, right, on the foreign exchange rate. Then its price is risk neutral pricing. All right. And then we do some magic here, right? By what? Factoring out the Q. And then we have 1, right? And then this, right? And so notice, right? Here you can do something very wrong like this. I can see that some student not remembering change of numerator formulation very precisely, right? Can just do this. I don't know, something like this, who knows, right? Because what's going on here, right? What's going on here is that this student might think that this is the change of measure kernel, right? And then just go straight to here. And maybe write something like this. I can already see that happens. So, right, you see how wrong this is. So what this says is, right, let me see here. Sorry, let's do one more thing. Let's say the student is not that, you know what, actually, somehow this student is still correct, even though, oh no, they're still wrong. Let me do this, right? So maybe, right? So when they do this, let me just pretend, right? They would continue. So they see that they need a discounting factor, right? So they will do this. And then they would do, right, discounting. And then they factor out K, right? Because you need that to turn that into the, like that, right? So they would get this. All right, like that, okay? So maybe this is not what everyone would do, but the student think like this, right? They think that this is a change of numerator, right? The kernel. So they just drop like this. But then they realize that this is not the proper pricing formula. They need discounting, right? So they add discounting, and then they compensate for that. And finally, right, I mean, to turn that to 1 for QT, right, you factor out extra K, right? So the student would get something like, right, the price of a call option, right, on the foreign currency is going to be E to RFT, right, times K shares of the, the price of the put option, right, on the reverse currency. However, right, this is wrong on many levels. The first error obviously is the E to RFT, right? That sounds unnatural. Why would that be there? Because both of them are at time 0, right? Both of them are at time 0. Why would that be there? That's the first error. The second error, right? So this is exactly the error of forgetting the discounting. The second error is about unit. Again, right? When you write something like this down on paper, it's very hard to catch your error. You have to really be aware of what you're writing. Well, this is in the unit of the dollars. This is in the unit of like euro or yuan, whatever. And these guys are really unitless, right? Because this is discounting, or this is risk-free. Risk-free has no unit. K here has no unit either because it's number of shares. In other words, right, from here to here is a wrong unit conversion. So what is it? They miss a Q0 factor somewhere. Okay, so that is that error. All right, so I want you to appreciate, right, that this is something that some of you might very readily do, right, and get some semi-correct formula, but actually it's not sensible, right? So, and again, right, the error traces back to them not using the right change of measure kernel, all right? Because this guy definitely is not a martingale, right? And this guy definitely does not have expectation 1. So what's the right step to do? So from here, right, the right step to do is you have to convert that, right, to the right martingale, right? So this is a martingale. You have to divide by its value at time 0, but at time 0, this is 1. So effectively, you just divide by Q0. So now this is the right change of measure kernel, right? So this is exactly the NT over N0. All right. So now what are we missing? We multiply by this, right, and divide by that. So we need to compensate. And now, right, this we can drop to the E tilde F. And so you see, right, we have exactly Q0, E tilde F, and we can bring the discounting inside. Right, and then we factor out a K as usual. And then we got this. Right. And that's exactly K, Q0, V0F. So maybe right here, let me just do put here, right? And this is V0 call, right? V0 call with strike K, V0 put with strike 1 over K, right? Because already that's 1 click, right? So this right conversion, right, corrects every mistake in between, right? For example, right, the unit is right. We have Q0, right, that convert this guy in a unit of euro or yuan, right, back to the dollars. And we don't have that weird, right, rate because both are time 0. Okay. Any question on this? All right. So then another thing, right, I want to say is, so I listed, right, all these financial examples, right, of currency conversion, money market, that kind of thing, right? So actually what I said last time was not correct in this way, right? So in pricing, we start out at domestic risk neutral probability. So in other words, what I say is this. So basically, right, another point of view of the domestic risk neutral probability is that it is a probability, right, such that the price of the asset, right, measured. So let me be more careful. The price of non-dividend, right? Now that we see it, paying assets denoted in the unit of the domestic money market is a martingale, right? Maybe I should say are martingales, right? Because I'm in plural, doesn't matter. Right, so what am I saying? It's really just the same thing as we've been always writing, right? But we slightly twist the point of view like this, right? Instead of saying discounting, we say price in the unit domestic money market, right? So we just want to put that flavor on. But another thing is now, right, we're very careful and say that non-dividend paying asset, right? Because what's a dividend paying asset? Q, right? Q is dividend paying asset. So if Q is a price of dividend paying asset, then discounted, right? QT cannot be a martingale, right? The last thing is that I say we start out. What do I mean by start out? So this is my mistake last time, actually. We do have a very fundamental, right, physical to risk neutral change of measure, right? But I think this is not change of numeraire. This is not change of numeraire theory, I think. The reason, right, is because when you think about it, right, the change of numeraire theory just does not apply to it in this way, right? It's still change of measure, right? It's still Gussanov, but it doesn't fall under change of numeraire theory because change of numeraire theory, right, requires that you start out with both martingales. But the whole point of physical probability is there's no martingale under it, right? Physical probability doesn't have a concept of martingale, right? Physical probability just talk about how things behave in real life, right? There's no point of view in physical probability. So therefore, it doesn't have that flavor of converting a martingale to martingale, right? So that's why I say start out. So the starting point actually is domestic risk neutral, right? If you want to look at that. So that's almost like our definition. That's our first numeraire, right? The conversion from physical to risk neutral is still a change of measure kernel, but it's not a change of numeraire because we don't have a numeraire under physical probability. So that's my mistake last time. This conversion is not a change of numeraire conversion, but right, the risk the domestic money market is still a numeraire, right, in that point of view. Okay. Any question about this? All right, so I just want to mention this, but I don't want to go in it too much. So when you do, right, when you do, let's say P tilde, let's say to P tilde F, right? Then definitely there's this kind of idea of W tilde right, going to W tilde F. All right. And then the question is, what is the drift change? Okay. So what do I mean by this? So remember, right, that our model for dQt, right, is like this: R minus RF Qt dt plus sigma 2, right, rho sigma 2 Qt rho dW tilde 1 plus square root of 1 minus rho square dW tilde 2, right? And we assert that dQft, right, is RF minus R QFT dt, right, minus sigma 2, right, Qt rho dW tilde 1f plus square root of 1 minus rho square, like that. So notice, right, already between these two, there's some magic going on. In other words, by magic, I mean, there are a lot of things, right, that make this happen that I write down very quickly, right? And I strongly encourage you to kind of see how, right, we can go from here to here very quickly, right? And it has nothing to do with the tedious calculation, right, of going from here to here. That's the technical details. But you can just go directly from here to here. Why? Because you know that the exchange rate, right, from the foreign side must have this kind of drift. All right. Because the discounted, right, under the foreign rate, multiply with the domestic risk neutral rate, risk-free rate, right, would convert that to the domestic money market, viewed from the foreign point of view, right? So this must be a martingale, so it must look like this. The minus because of the division, sorry, this is QF, right? The minus because, right, of the division. So the exponential, right, when you write down the exponential formula, it will give you a minus. All right. So that leaves us with the question, right? How are these two connected? And how are these two connected? Right? That's what I mean. What's the drift change? Well, how do you know? Well, now you just really, the only way to do it is to write down the change of measure kernel formula. So E tilde F, right, is E tilde, right? What we say was E to RT, sorry, E to RF, right? QT, and then discounted divided by Q0 times X, yes? And this is a bunch of blah, blah, blah. But, right, remember, what does the Gasanov theorem say? Gasanov says this, right? If ZT is E to the minus, right, 1/2 theta square T minus theta WT, right? And you define P tilde, right, which is E of ZT times X. Then, right, W tilde, which is W plus theta times T, is a P tilde martingale. Sorry, P tilde bar motion. So what that means is you just have to look at the exponential structure of the change of measure kernel. More specifically, just look at the coefficient, right, in front of the Brownian motion. Then that will be exactly the drift term in the new Brownian motion. So, right, what is this guy really? I mean, sorry, what is this guy, right? In this point of view? Well, you can see that, right? Let's call this, right? Again, I'll call it ZT as well, right? So that ZT will be, right, or let's call it ZQT, right, will be what? E to the, right? Notice those are the only ones. So minus 1/2, let me just do this, right? Theta 1 square plus theta 2 square of T minus theta 1, W tilde 1, minus theta 2, W tilde 2, where theta 1 is rho sigma 2, and theta 2 is square root of 1 minus rho square times sigma 2. Agree? Because those are exactly those guys. That's ZQT. I'll pause here a little bit for you guys to take it in and see that is correct. Any question about this? Are we okay? So I hope then, right, that you see then what the connection between these two guys now, right? What's the connection? Well, W tilde 1F will be W tilde 1 minus, right, rho sigma 2 times T. Why minus rather than plus? The reason is because, oh, sorry, this is plus, right? This is plus, yeah. The reason why this is minus rather than this plus is because the ZQT in this solution, this is plus rather than minus. Okay. Similarly, W tilde 2F will be W tilde 2T minus. So that's the connection. All right. And you can really check that when you solve out these two guys, right, like this, with this identity, right? So let me call this 3. This is 2, right? And this is 1. Check that they are consistent. What do I mean by that? What I mean is, right, you write down the formula for QT under this, you write down the formula for QFT under this, and you divide, and then you use the conversion, then everything should match, right? No wrong factors anywhere. All right. Nevertheless, right, it'll be a little bit tedious to do that. But if you don't trust these calculations, you should. I strongly encourage you to do that. And the message here, right, is that I hope you kind of see, at least, right, that there are some kind of shortcut and, you know, intuition that we apply here, right, to avoid doing all this dirty math. Meaning that this is why, I don't know, right, people in this business, this is why I can see these things much faster than you do, right? It's not because I'm, you know, smarter than you or anything like that. I have much more experience. I know what to expect, right? And so the first time you see this, definitely you will feel very overwhelmed, right? With so many symbols, so many things. The only thing I would like to convince you is that it's natural, like it's the way it's supposed to be, right? So try to think about this until it feels natural to you, right? That's the only thing I can recommend you to do, right? But if it doesn't feel natural, at least do yourself a favor and check that things are consistent. And then maybe from there, right, you can start thinking. Okay, question. All right. So now let's address maybe one of the most important question here. Why change of numeraire? So someone tell me, right? All these theories, they look so fancy, right? What's the point? What do you think the message is here? Why do we do all this fancy stuff? What have we been doing so far in this chapter that seems to be of any value? If you have to explain change of numeraire to some people, what would you say? Why do you study it? Notice, right? The foreign currency concept does not need change of numeraire to be discussed, right? Everything can be done just mathematically under the original model, right? I didn't write it down, but you don't need. So change of numeraire is about the new probability, right? Change of numeraire is about the new probability, right? Why do we need it? Or why do we want it? Right? What does it do to us? What does it add? You should ask yourself this kind of question, right? When you study something, what does it do to you? What advantage, what value does it contribute? So after I try to sell this kind of thing, maybe, what do you think? So first of all, right, I want you to appreciate this, that there are, in this course, right, there are two things that may be a little bit confused with each other. The first is the point of view of modeling, right? So you learn Black-Scholes model mostly in this class. We talk about binomial model, right? And maybe mean reversion model, that kind of thing. So that's the first of all, right? That's the modeling point of view. But that's really any branch of math would have that, right? So this course, I try to teach you that, but that's not really the unique point about this course. What's unique about this course is about point of view, which is really the risk neutral one. So change of numeraire actually is about point of view. And it's really not about modeling at all. Okay, and that's why it's a little bit more subtle, right? So you should remember why we want to do risk neutral probability, because we want to adopt that risk neutral point of view, right? The asset is still the asset. The stock is still behaving like the stock, right? So just because you change the point of view doesn't mean that the path of the stock changes in any way. What changes is the measure, right? The likelihood that you assign to the path of the stock, right? You change the point of view, you change the likelihood, you change the probability on how you look at the stock, right? So change of numeraire, again, is really a change of point of view. So basically, the message of change of numeraire is that things look right under the right point of view. All right. And you're like, what? because that seems like some abstract nonsense, which is, more or less, yes, right? If you know what I'm talking about, then you know what I'm talking about. But if you don't, then you might think I'm talking nonsense. Well, let me try to convince you, right, on why this is true. So first of all, right, the first message is very clear right here. That notice that the put-call duality, right, that we derived here, right, one share of a call option with strike K is K shares of the put option with strike 1 over K, right? If we do not change probability, then we will never derive a neat equality like this. Okay. In other words, this put call duality can only happen because we switch from E tilde to E tilde F. So that's the easiest thing to convince you that that's the right way, right? Notice that if we still insist on keeping E tilde, then you got this mess, right? And even if you factor out a K, you still get this mess. So under the risk neutral, right, the domestic risk neutral, then you have to interpret this whole thing as an asset. But what the heck is it? It's nothing, right? So only until you take this out as a change of numerator and you change the point of view, right? So basically you insist on keeping this, only this as the asset, right? Maybe factor out K, but you only insist on keeping this as an asset and this gets absorbed into a new point of view. Then it looks right. All right, it looks intuitive. So that's the one thing. Okay. Another, so the first example you should keep in mind is put call duality, which is not possible without change of numerator. The second one is this. The second one is the dynamics of, right? And let me just do this, right? Okay, so now let us do this. Let me ask you this. Do this look natural to you? Are they even beautiful, if we want to use that word? Do they look good? Do you think that these things must be this way? Or do you think that this is unnatural or whatever? I don't know. Do they look natural? Yeah. Yes, thank you very much. And I forgot that minus QF. Yep, thank you. Yeah, right, because the minus is because, right, the relation is QT is 1 over QF, right? QF is 1 over Q. So I hope the answer is yes, right? Maybe the lack of response because you think it's so natural. But I just want to tell you that it's not so natural in this way, that or automatic. In fact, there's a whole paradox is behind this. All right, and every time you hear there's a paradox, that means there's some conceptual, significant conceptual thing going on here. And the paradox is this, and let me show you, right? It's called the Seagal's exchange rate paradox. And by the way, this is your textbook, right? It says this, right? I'll let you read this for a little bit. So first of all, right, notice that it exactly refers to the right? The return, right, of the Q and one over Q, right? And they say that, right, this should not always happen. And here they give an example, right? From 90 euros to the dollar, that will be if the I don't know if the exchange rate goes like this, then the exchange rate fall by 5%, right? On the other hand, the other one, right, rises by 5.26%. Okay. And they mentioned about the convexity, blah, blah, blah. And right, they mentioned that you should expect like this. Okay, and that's all your textbook does, because then, right, they would do some math and they would tell you how things work out like that, right? But let me ask you, right, and this is so famous of Sharif, he does the math very beautifully. His concept is kind of weird. Why would this be a paradox? Anyone can tell me what the paradox is in this case? So right here, right, they explain this to be a paradox. So they say, right, in real life, right, if one exchange rate goes by falls by 5%, the other one rises by 5.26%. Okay, which is true, right? That's what the math does. This is, by the way, this is physical probability right here. I think this is physical, I believe. But then they say, right, somehow you expect this. But who in their right mind will expect this? Do you? So actually, right, this looks very natural, at least when I read this. And then I'm like, why the heck would they call that a paradox? A paradox means that you expect something to happen, so it doesn't. Right? But here you don't expect this, right? You expect this. So why would they call it paradox? Or do you guys feel like this is a paradox or no? You understand what I'm trying to say? Okay, so I'll let you absorb that. But that's the point I want to make that here. I'll show you something more, but right. So first of all, at least, right, the point that Sharif tries to bring up is this is not that natural or not automatic. Okay. But again, right, in math, it feels so natural to write this down. But yet, right, and maybe the paradox is, why does Sharif call this a paradox? Right? What is the paradox, right? What is the paradox? So in fact, right, the Sharif is not the best source for you to look at that. But the best source is Wikipedia, maybe. And let us look at Siegel's exchange. Yeah. All right. And here again, I'll let you read that a little bit. So here, right, is where I think they explain it. So basically, right, they say that suppose you have a country that sells apple, the other one sells orange or prefers whatever. And the exchange rate right now is 1-for-1, right? You can exchange one apple with an orange. But in the future, they can change to either 2-to-1 or 1-to-2, right? So they can do that 50-50%. And then here they explain to you that if you look at from the Apple's point of view, I think they say that the Apple will expect to, hold on. So let me tell you the conclusion. The conclusion is that when this happens, both countries, right? So right now they're indifferent, right, between Apple and Orange. But with this point of view in the future, the Apple country will prefer orange, prefers the whole orange, and the Orange country will prefer the whole apple. So in other words, when this happens,
even is equally is perfectly symmetric, then for some reason the Apple country will prefer orange and the orange country will prefer Apple, because they will both seem more attractive. Orange becomes more active to Apple and Apple becomes more attractive to orange. And that's a paradox, right? Because it cannot be that somehow, right? So both of these guys are more attractive to the respective country, and that's the paradox. You understand? So right, I think here they will try to say that the Apple now see that for them, right, one apple will be worth more than one orange will be worth 125 apples, so they prefer orange. But from the orange point of view, exactly the same happens, right? One apple now is worth 125 orange. So now Apple is more attractive. Okay, so do you understand that? So that's why it's a paradox, because what is more, which one is more attractive now, right? It cannot be both can be attractive, right? So you can read the wine example to get it to be more clear. But so the paradox is that, right, somehow when something like this happens, the foreign currency becomes attractive to both countries, right? But it cannot happen because it can only be either that one currency is more attractive, the other must be less attractive, right? That's the point. Okay, so that's the paradox. And so do you see any do you see anything how that paradox is connected to whoops, I'm not sharing. Oh, I know, sorry. Okay. So, right, do you see how that paradox is connected to this whole thing? Right, so the paradox is, right, that if, let's say, right, QT can rise by 50% of like this or fall to 50%, then what happens is that, right, QF is more attractive to QT, right, to domestic, I guess, or I don't know. And then Q is more attractive, I'm not sure if the other way or whatever, to for, right, maybe the other way. But basically, that's a paradox because, right, if this is more attractive to one, then the other one must be less attractive to the other. Right? So where is this? How do you resolve the paradox? And right, so if you look at, right, both of them, they mentioned something to 1 over x being convex. So let me tell you, right, here's the solution to the paradox. There are many solutions to the paradox. You can read the Wikipedia page, right? And you should, in fact, think about this a little bit. The solution is this, that basically when you do this, right, it's a paradox because, right, so basically both becomes more attractive to both. The reason is because you are not looking at it from the right point of view. From the right point of view, if QT goes up by 50%, then 1 over QT decreased by 50%. So no preference change. You understand? So basically, if you look at, so but notice the right point of view is you must look at the
this exchange rate under P tilde, and you must look at this exchange rate under P tilde F. Then, right, if one rise by 50%, then one will fall by other 50%. So therefore, the net change will be 0. So there's no preference change. And that's exactly what Ship was trying to say here in his blah, blah, blah. That basically, right, if this were to happen, then nothing will change. In other words, the preference will be the same. But if you don't, then you can have the case where view from one point of view, right, the currency is more attractive in one case, and view from the other point of view is also more attractive from the other guy. And that arises in paradox, right? So this one is more subtle, and I will let you to contemplate that, right? I mean, I can only say so much. Let me tell you about the 1 over x as well. What does the 1 over x have to do with anything? The 1 over x being convex, and they mentioned Jensen, right? It's like this. Expectation of 1 over x is always, I think, less than or equal to 1 over expectation of x, I think. Is it more or less? One of them, I forget. Either more or less. Hold on. Probably whatever. But the point is this, right? So because basically there's this inequality, all right? So because the exchange rate is exactly 1 over x of each other, right? So because of this, this is why whenever you apply the 1 over x, you always get a higher or lower than the average expectation. This is why when you have a 50-50 change, the point of view of the other guy always looks better because you do 1 over x. From whatever standpoint you have, you will convert from one to the other by 1 over x. But if you take away the convexity, right, by applying the right point of view, then you will no longer have the inequality like going like this to change your preference. So that's what happens there. Okay. Anyway, I'll stop there, right? So maybe the last thing for change the numerator is this. It has to do with forward rate modeling. Sorry, forward price model. And this actually belongs to the interest rate chapter, which we don't get to in this class. So let me tell you quickly what it is. So notice, right, before we always price like this. V0 is E tilde, right? E to minus RT. And let's just say something like this, right? Phi of ST, right? Where R is a constant. But what you really want is R is a stochastic process. In other words, maybe something like this. And here exactly, this is, mean reversion model, right? The risk-free rate can follow a mean reversion model. If the risk-free rate follow the mean is a stochastic process, then your pricing formula will be like this. Okay. And because, right, this is a stochastic process, this will be impossible to, find analytical formula. Not only that, it's impossible to also do Monte Carlo simulation. Why? Because you see, this is almost like a path-dependent option, right? Where this is like the Asian part being on the interest rate. All right, and not to mention some interaction between these two guys. So, right, but if you want to make your model more interesting, this is what you have to do. So what's the solution? The solution is like this. the solution, it's not the solution, but a possible approach. A possible approach is this, that, well, maybe the risk neutral probability may not be the best one to deal with when you have stochastic rate, okay? But what's a better one? Here's a better one, right? First of all, notice that now, right, the bond price is no longer deterministic, right? Because a bond, right, is exactly a object such that it pays $1 at time big T. But at any time before that, it will have some stochastic pricing formula. So here's little t to big T of RU du condition ft. Okay, this is discounting from T to big T of this. All right, so before, right, before the bond price is basically just this, so we hardly pay attention. But now it's this, right? So, but the bond price no longer deterministic, then what do? What that means is actually forward price is no longer deterministic. Remember, right, what is forward price, right? So notice, first of all, right, let's revisit the pricing for the forward contract, right? So before, right, VT is like this, right? When you write V little t, it will be ST minus K e to minus RT minus T, right? When R is constant. Now, VT will still be ST, but this will be the bond. Okay, now it will be the bond. So if you want to set this equal to 0, then K will be ST over BTT. And that's exactly what we mean by the forward price. So this is the forward price to enter at time little t, right, on the stock to have maturity at time big T, right? This is the price you can enter at time t, right? So the contract has price 0 at that time. So now going back to, right, this pricing option, right, what do? Notice, right, that the forward price at time big T will be S big T over BTT, which is exactly just S big T, because the bond price at time t equals to 1. Therefore, right, when you do the pricing like this, right, you can also think of this as the pricing of this, right? Because this is always equal to 1, right? But guess what? Since you're already dividing by the bond price, right? Why not use the bond as numerator? Here. That's exactly that guy. Right. So in fact, now we actively use the bond price as a numerator. So we will, right? So what is the effect of that? So the effect of that, right, is this, that basically, right, you define ST over BTT, right? Which is exactly, notice, right? This is exactly, you can discount it back. Because, you know, the discounting, right, will be canceled out on both sides anyway. So the point is, both of these are martingales, right? then, right, the change of measure will give you what? This will be E tilde, right? The change of measure kernel will be BTT, right? E to minus 0 to T RT dt divided by B0T, right? And then this. Do you agree? And then, right, so basically you have to, I think, multiply this out. But then this will be B0T times a forward measure on this guy. And let's call this the forward stock price, right? Okay, so what do we gain? What we gain is in this pricing, no interest rate shows up. And so, right, what you do is you model the forward price process. In other words, you model DS forward price, or, you know, if you want, right, you can call this FTT. And for a reason that we don't go into right now, it has no drift. It has no drift. The reason is already, you know, like under the bond, you have the forward price of the market. But anyway, the point is that when you use the bond as numeraire, it opens up a new modeling approach where instead of modeling the stock price itself, you model the forward price. All right. And when you model forward price, you do every pricing under this model, under this framework, then things become easier, right? So when the moral of this thing that I will tell you is, when the interest rate is random, then the domestic or the original risk neutral probability is no longer the right framework to look at. But the forward price will be the right framework to look at. Why? Because the forward price already incorporates the interest rate into it. Okay, it's almost like, right, foreign currency already incorporates, right, the conversion already incorporate the foreign currency fluctuation into it. All right. So again, all these calculations may look a little bit crazy, but the philosophy of change in numeraire, right, is still there. And that, okay, for better or for worse, it's not something we cover in this course, but I encourage you to read that in Shri, for example, to have some taste. All right, so that's it for this semester. Hope you enjoy, and I'll see you on Thursday.
Thank you, Professor.
Hi, Professor. Can I ask a quick question?
Yep.
I have a question about like the example you raised in class about the two Brownian motions path in one pricing. I'm wondering. I'm sorry.
I was just talking to Yifei. Yeah, don't worry. Go ahead. Yeah, the two Brownian motions. Just
Yeah,
leave it.
yeah. I'm sorry. You can go ahead.
No, I already talked to him. Go ahead. What's up? Yeah, you can ask your question now. Sorry.
Okay, thank you. I'm wondering like why the two change of measure like have the minus sign, like the W tilde T1F and W tilde T2F. I'm wondering why they have like two minus signs after like change of measure.
Yeah, one moment. So the reason, right, is because of Gasanov. Gursanov, right, says that if this is the kernel, and notice Gursanov's very strange, is a minus here.
Yes,
Then you got a plus here for the drift,
yes, yes.
right? Actually, this is like we looked at this also in the Berry option. We have something similar like this too. So now, right, when you look at the Q, right, that is the foreign currency model that we use, right? Notice that in the Q, right, this is plus and this is plus.
Oh,
So
yes.
it comes out to be plus here, right? That's why I say
Oh.
I wrote it wrong to begin with. I wrote minus. I was wrong.
I'm sorry. I made a mistake about this kind of.
Oh no, it's very easy to make mistake. I do that too, right? But
Yeah,
these
so
are
I'm
things
like really curious about why you got the minus M after that. Oh, I see. I should change my minus to the like positive
It
sign.
was a plus here. Yeah, it's a very annoying thing, but it can cause some errors down the road. Yeah, absolutely.
Yeah, thank you so much. I made a mistake here. So
No, it's easy to do that. I do that too. Yep.
yeah, thank you so much.
Okay.